Hello everyone. In this lecture we will discuss Maxwell equation in matter. We know that Maxwell's equations in vacuum are, that is, divergence of electric field equal to rho over epsilon naught. This is a Gauss's law. Then divergence of magnetic field is equal to 0. No name of this equation. Then we have curl of electric field equal to minus curly by b by curly t. This is a Faraday's law. And then curl of magnetic field equal to mu naught J plus mu naught epsilon naught curly E by curly T. This is a Ampere's law with the Maxwell correction. So here this is a Ampere's law with the Maxwell's correction. Okay, so this is a correction factor. So this is a correction factor. So here these are the equations in the case of a vacuum. Now here in matter, if we consider this equation in matter, then in matter, this row of this first equation, that is a volume charge density, this is equals to rho f plus rho b. That is the volume charge density for free charges and volume charge density for the bound charges. So here we know that this rho b is equal to divergence of P. So P is nothing, this is a polarization. So here in case of a matter, this rho, that is a volume charge density, is equals to free charge density minus del dot P. So now we will substitute this value in the first Maxwell equations. So we can write del, that is divergence of electric field, is equal to 1 over epsilon naught. Here we have a rho f minus divergence of polarization. Or we can write this equation like this, that is epsilon naught divergence of electric field, and this is equal to rho f minus divergence of polarization. Or if we couple these two, we can write divergence of epsilon naught E plus P, this is equals to rho f, and this factor, that is epsilon naught E plus P, this is the D, that is electric displacement vector. So this is equals to rho f. So here in matter, in place of a del dot E equals to rho by epsilon naught, we have a divergence of electric displacement vector, and this term is equals to free charge density. Similarly, in case of a matter, the volume current density, that is J. Here in the fourth question we have a term J. This will modify. So according in the matter, this volume current density is equal to JF, that is free current density, plus BJB plus JP. So this JF is the current density for free charges, then this JB is the current density for the bound charges, and JP is the rate of change of polarization with respect to time. So we can write this JF in place of a JB. We know this is equals to delta cross M. M here is a magnetization, plus this is a curly P by curly T. This is a polarization. So JP is equals to rate of change of polarization with respect to time. So now we will substitute this J value in the fourth Maxwell equations. So we can write del cross B equal to mu naught. In place of a J we can write JF plus del cross M plus curly P by curly T plus mu naught epsilon naught curly E by curly T. Okay, now here we will divide this equation by mu naught. So we can write 1 over mu naught del cross B, and this is equals to JF plus del cross M plus curly B by curly T plus mu naught will not be there. We have a epsilon naught curly E by curly T. Now we will couple this curl factor, or we can write 1 over mu. We can write del cross 1 over mu naught B minus M, and this is equal to JF plus curly by curly T. Here we also couple this curly factor, so this is a P plus epsilon naught E. So here this 1 over mu naught B minus M, this is nothing, this is the auxiliary field, that is H, and this factor as we discussed epsilon naught E plus P, this is equal to D factor. So here 1 over mu naught B minus M, this is the auxiliary field H, and P plus epsilon naught E is equals to electric displacement vector. So finally we can write this equation like this, that is final equation we can write like this, that is curl of auxiliary field equals to JF plus curly D by curly T. So this is the fourth Maxwell equation in matter. So finally Maxwell equations in matter are first, that is divergence of electric displacement vector is equal to rho f, then divergence of magnetic field is equal to 0, then curl of electric field equal to minus curly b by curly t, and curl of auxiliary field is equal to jf plus curly d by curly t. Okay, so in this set of Maxwell equation, there is only change in equation first, that is Gauss law, and in the fourth relation, that is the Ampere's law. So there is no any change in the second and third equation. Okay, thank you.